Hello everyone, in today's video I will be solving a problem based on conjugate beam method. So now this is the problem. Here it says that find slope at A and deflection at C by using the conjugate beam method. So here this is the question and we have to find the slope at this point, at A point, and deflection at C point. Okay, so now before starting a problem, I'll draw a free body diagram of this given question. So here, okay, so here I'll draw a free body diagram here, and this is a point, and this is a B, and this is a C point, and this one is a D point. Now at this C point, one load is acting, that is 50 kilo Newton, and the distance from A to B is 2 meter, and from B to C is also 2 meter, and from C to D is 1.5 meter. Okay, so this is the free body diagram, and here in the conjugate beam method, first step is to find the bending moment diagram. So now to get the bending moment diagram, we have to find the here RA value as well as RD value. RA is nothing but reaction at A and RD is reaction at D. So here in our strength of material subject also, we have already discussed about all those, like how to find the reaction at particular points. Let's start. So now here, to find the RA and RV value, what we have to do is summation of all the vertical force is equal to 0. So here that means sum of all the upward forces is equal to sum of all the downward forces. Okay, so now here what are the upward forces? That is RA and RB, right? So here sum of, so it will be RA plus RB is equal to how many downward forces are there? Only one, that is 50 kilonewton. 50 kilonewton. Let it be equation 1. Now again we have to do summation of all the moment about A is equal to 0. Okay, so here summation of A means this A. Okay, so now here in this moment what will happen? All the forces will come towards A, and whenever if we find the moment, always remember we have to consider the distance also. So moment is equal to load into distance. Okay, and this is very important to remember. Now here to reach at this point, what happened? RD, this RD into, to reach at this point RD, this forces will cover how much of distance? Total distance is 5.5, right? 5.5. Again at C point, one force is there, that is 50 kilonewton. Now here see, we are considering upward forces as positive and downward as negative. Okay, so here RD will be positive, and this value, this forces will consider as negative, minus 50 load into distance. Distance means from here to this value to reach at A is 4, right? 4, and at B there is no other forces, so is equal to 0. Okay, so from this equation we can easily find the value of RD. 5.5 is equal to 50 into 4, so RD is equal to 50 into 4 divided by 5.5. So we'll get the value of RD as 36.36 kilonewton. Okay, so now we have a value for RD. Okay, this one was RD, right? So now what we have to do is we have to put this value, this RD value. RD is equal to 36.36 kilonewton. So we have to put this value in equation 1. So I'll write down here like this. Put RD is equal to 36.36 kilonewton in equation 1. So this was equation 1, that is RA plus RD is equal to 50. So RA plus RD is equal to 50 kilonewton. So RA plus RD value is 36.36 is equal to 50. So we can easily get the value of RA. That is RA value is 13.63 kilonewton. So now we have a value for RA and RD, right? Now, sorry, this is RA. Now we have to find the bending moment at B and C. Okay, so I'll draw the diagram here. It was like this. Okay, so it was like this. Again, this one was like this. This was the question, right? Why it's coming like this? Okay, now here one load is acting, that is 50 kilonewton. Let it be it was A, B, C and D of 2 meter, 2 meter and 1.5 meter. Now we have to draw a bending moment diagram of B and C, right? 2I, it was I and it was also I. So now what we have to do is, now we have a value for RA. RA is equal to 13.63. This is B, this is A and this is D and this is C. C 50 kilonewton and RD value is 36. What was RD value? 36.36. 36.36. Okay, so now we have to find the bending moment of B and C. So I'll solve this side. So bending moment at C point, at this C point will be RD is 36.36 into this distance is 1.5 is equal to 54.54 kilonewton meter. Okay, now again bending moment at B. So here this value 36.36 into the distance is 2 plus 3.5, right, and then again minus 50 into to reach here is 2 meter, then we'll get the value around 27.26 kilonewton meter. So now here C, here we have to find the bending moment at C and D, right? So bending moment, always remember moment is equal to load into distance, right, as I have already mentioned. So now here load, so if we are finding a bending moment for this point, so what will happen, this load is only there, right? This load and this load covers a distance of how much? 1.5 meter. So it will be 36.36 into 1.5 meter, and we'll get the value around this one. Now again we have to find the bending moment at B point. So B point, this load will act and it will cover a distance of how much? This one was 2 meter and this one was 1.5. So total will be 3.5. Again one more load is acting here, 50, and to reach at this point how much distance it will cover? 2 meter. So we'll get the value around 27.26 kilonewton. Okay, now and for a simply supported beam, this RA and RD value will be 0. Okay, now we'll draw a bending moment diagram. So here at A, and this is B, C and D. So here B is 54.54 and C is 27.26, right? So A, B, C, D, A, B, C and D, right? So here at C point and at B, C point will be okay, sorry. So here C is maximum, right? At C point is 54.54 and B is 27, okay, 27.26 somewhere. Let's consider somewhere here, and again 54 will be maximum and it will go to 0. So now this is our bending moment diagram. Now again we have to draw the M by EI diagram, right? So now to draw the M by EI diagram, you can check my previous video also. So here M by EI diagram, what will happen? A, B, C and D. Now here see, here from A to B it's I and 2I, right? So now for M by EI diagram, just we have to EI diagram. So for this point it's 27.26 and from A to B the I value is 1, right? 1. So it will be divided by 1, then it will comes like this only. But here at this B point, what happens? See the question. At this point, one is shared with the I and the other is shared with the 2I at this particular point. So in those situations, what we have to do is, for the same value, first we'll divide with this value and again with this value. So here the maximum bending moment was 27.26 for I. Now again at particular this point is also shared with the 2I also. So now what we have to do? 27.26 divided by 2. So we'll be getting the value around 13.63. Okay, so 13.63, it's lower point, right? Lower, it will be 13.63 by EI. Okay, I'll rub this point now. Again B point is okay, and again for the C point for it's also same, one is shared with the I and 2I. So now first we'll do for the 2I value. 2I means like we have a value of maximum bending moment at C point. Now we have to divide this one with 2, so we'll get the value around 27.25. So it will be somewhere here. Okay, I'll rub and I'll draw somewhere. I'll write it somewhere here, 13.63 by EI. So we'll connect this part. Okay, and the maximum bending moment is 54.54. This will be 0. So this is the M by EI diagram. Done. Now what happened? We have to, in the question what it says that we have to find the slope. We have to find the slope at A and deflection at C. And to get the slope at A, what we have to do? We have to find the area of this M by EI diagram. Let's solve the area now. So for A to B distance, we'll find the area. So what we'll do, see, for this bending moment we can't find the area directly. So in this case what happened, we'll divide this from A to B, from B to C, okay, this term is C. So now we'll divide like this. So first we'll solve for a to B distance. Now for A to B, the bending moment diagram is like this, right? So, and the value is 27.26 and the distance of A to B is 2 meter. So we know the formula of area, that is area of a triangle is half into B into H, right? So half into base is what? This 2 into height is this, that is 27.26 is equal to 27.26. This one and this one will get cancelled. Then the area is 27.26 meters square. Okay, now again we'll solve a right like this for B to C, and our diagram is like this, right? So for this case what we'll do, we'll divide this into two parts like this, B to C, and B to C is also 2 meter distance, and the height is B to C. So like this. So B to C, the total height is 27.25 and this height is from here to here is 13.63. okay, from here is here, this is the height, and the whole height is this one. So now we'll find for this area first. Okay, so here this area will be the whole distance minus 13.63. if we'll do, then we'll get 13.62. okay, 2 meter, and the area will be same, the formula half into B into H is equal to half into B will be 2 and H will be 13.62, and the value will be 13.62 only. This one and this one will get cancelled. Now we'll consider for the second this area, okay, so this area, and the height is 13.63 and the distance is 2 meter. The formula will be same, area is equal to, oh no, for a rectangular it will be length into breadth, and length is how much? 2 into breadth is 13.63, and we'll get the value around 27.26. okay, now we'll solve for C to D. So here for C to D. Okay, so now this is the whole diagram, right? This is the, so let's draw here the area. Now the height is 54.5 and the distance is 1.5, and area formula will be half into b into height is equal to half into b will be 0.5 into height is 54.5. So we'll get the value around 40.87 meter square. Okay, so our motive is to find the slope at A. So to find the slope at A, let's draw the free body diagram now. Okay, this is RA, RB. Now here at A to B, this is the area, right? So this area will be somewhere here, and the value of area is 27.26, but we don't know the distance of this load where it's acting. So we know that this was the A to B bending moment diagram, right? So now from what was the and the CG will act at the center, and we have a formula for finding the CG for this rectangle, this triangle, that is from this edges it will be 2/3 of the L, and from here 1/3 of L, right? So just 2/3 of from here to here, it's a 2/3 of L. 2/3 of L is nothing but A to B L is 2, 4/3, 4/3, that is 1.33. Okay, so the whole distance was 2 meter. So from 2 meter to, if we subtract 1.33, then the remaining distance will be, we'll get the remaining distance, right? Just solve it. Okay, now again here at B point, B to C point, what happened? We have a two area, one is 13.62 and the other is 27.26. okay, so here let's solve. 27 here, 13.62, so 13.62 it will take somewhere here, and 13.62 here also the same CG will act at the center, and from here 2/3 of the L, 2/3 of the L, then again the distance we'll get from here to here is 13.33. so remaining will be, the whole distance was again 2 meter. Here it was 13.62, right? 0.62. Now for this rectangular section, the CG will at the center, so it will be half, right? 1 and 1 distance 1 meter, so 1 meter means somewhere here. Okay, and the load is 27.26, and the distance from here is 1, and from here to here is also 1 meter. Now again for the last, we have to find, this is the for the last, and the distance from here to here is 2/3 of the L, 2/3 of the L, that is the whole area was 1.5, so it will be 1 meter, so it will be 0.5. so this is nothing but the free body diagram. Okay, so now we'll do summation of all the force at A is equal to, so for this this is D, right? So now we have to find the summation of all the force at A, that will be A, that is RD value is RD into the whole distance is 5.5 minus 40.87 into this whole distance is 4.5 minus 13.62 into 3.33 minus 27. Okay, 27.26 into 3 minus 27.26 into 13, 1.33. Okay, so here I'll explain you again. See, this is the free body diagram. Okay, and we have to find the RD value. So RD value will be different because it's a final free body diagram. Okay, so now if we take summation of all the force at A, then what will happen? See, this force, this is a force, right? This force will cover a distance of 5.5 to reach at this point, right? That's why it's RD into 5.5, and we know that the moment is equal to load into distance. This is the load, and distance, how much is covered? The whole distance is covered to reach at this point, right? Now upward forces we are considering here as positive and downward as negative. So minus, again, see, 40.87 will cover 4.5 distance. From here to here it's 4.5 to reach at this point, right? So that's why it's 4.5 minus again 13.62 from here to this distance. It's covered 3.33. Okay, minus this is 27.26 into this load will cover this much of distance. Okay, so that is 3. Now minus 27.26, this load cover 1.33 distance to reach this points. Okay, so from here we'll get the value for RD, that is RD is equal to 63.65 by EI. This whole load is EI. Okay, so I have not mentioned here. At the last also you can mention easily. So now we have a value of RD for the final free body diagram. So here our motive is to find the slope. Okay, so let's find the slope at E. Now to find the slope at A, what we have to do here, RA means like slope at A, you can write RA or slope at E is equal to the area of M by EI diagram, right? So we have already drawn this M by EI diagram. This is the M by EI diagram, the area, and we have already solved all the areas, right? So here, and these are the values for the areas, right? So we have to write all, that is 63.65 minus plus 27.26 plus 27.26 plus 13.62 plus 40.87. So we'll get the slope value in 45.86 divided by EI. Okay, so this is the slope at A value. Now the second is to find the deflection at C, right? So deflection at C. Now deflection at C, we have a free body diagram here. So here up to here we have to find the deflection at C. So now deflection at C, deflection is denoted by this term. Deflection at C is equal to, see the diagram here, to reach here, this is the load, and this load we will consider only this part. Okay, so now here this load is acting at this beam, and this load covers a distance of this much, that is 1.5 to reach at this point, right? So what we'll do, right, that is 63.15 into 1.5 minus, again one more load is there, that is this load, that is 40.87. 0.87, and this load covers a distance of 0.5 to reach at this point. That is 40.87 into 0.5. So now from here we can find the deflection at C, that is 74.29 by EI, kilo Newton per meter square. So here we have got the value for slope as well as for deflection. That is, slope at A is equal to 45.86 by EI, and the unit of the slope is always radian, okay, and deflection at C is equal to 74.29 by EI, kilonewton per meter square. Here the unit is radian. Let me highlight it. So this one is okay. So I'll see you in our next video. Thank you.